So what are you going to base that communication on that makes the communication personalized? We decided to base it on several things. One is dropout predictions, which have been overly studied by now in terms of a modeling objective. So much so that there's even multiple papers now on frameworks for evaluating multiple dropout predictors. So they're at the meta level now in research. But what there's not a lot of is, what good are these predictions? How do we bring them to bear to make some impact on the student experience or learning experience? And so we had that in mind. So we trained models to predict the probability of a learner dropping out, and we generate this prediction every day. The probability of a learner completing the course, which means they will turn in enough material to have a chance to pass. And then the third prediction is if they're going to pass the class. Okay. And again, we use our favorite model here, a form of recurrent neural network. We will be forced to use fancier and fancier things like transformers and so forth, but in 2018, we used RNN. And I want to draw attention to the inputs here. So the predictions of in this case, certification, which is passing for us, are made at every event. So every time the learner clicks something, a new prediction is generated by the model. And the inputs to the model is the learner's events, sequence of events, which is a simplified click stream. So sequence next is when they click the next button, loading a video, sequence go-tos when they click on that accordion view to specifically go to a particular vertical, and then let's say a time marker that week 4 endpoint has been reached. I want to point out that these course inputs, these inputs are course general, which means we train one model based on dozens of courses, and it doesn't need to be retrained for another course. So we can make this model public, and you could use it for your course without us having to get your data and then fine-tune the model. And we've now trained this on over 100 edX courses, and are working to set up a persistent Oracle service that can work for any course query. Okay, but initially this was trained on 20 courses with 13.6 million clickstream events. Here you see all 100 courses we had, and then the subset we decided to use for this study, and upcoming studies using more. And then the median duration of those courses, unique deadlines, certified students. So there was some variance, right, in the lengths of courses and so forth that you might expect, but the evaluation is still on how well our models generalize across courses of this variance. And the result was higher the better here in predicting, in this case, dropout. The best predicting model was the neural network, but more exciting was that almost equal to that was a linear regression. So we go with linear regression now for our modeling. Neural network not required. So for the next step, now that we've figured out, okay, what is a pragmatic and good predictor of these outcomes, we now want to surface this in a way that it's useful, that again gets us to our original aspiration of tailoring communication. So we designed this interactive dashboard that displays a histogram of the probabilities of all the learners for completing, for dropping out, we say attrition, and passing, which we say certification. And then the instructor can select a subset of this group to then send an email to. So you could email learners who are predicted to complete but not pass, and say, we're coming up to a really important topic that can lay the foundation for the rest of the course. Here's some videos that I have not included in the site that others have found useful in the past. Maybe you link to some Khan Academy or what all. But it's up to the instructor, right? If you have office hours, or when you've talked to a student, you don't necessarily know exactly what you're going to say to every student. You have to get some feedback, and then you decide how you're going to tailor your response to them. So same thing here. I'm not prescribing what an instructor will say, but it gives them the ability to personalize by selecting a subgroup of students, albeit not a single student, but it's better than sending to everyone, because you probably wouldn't send that kind of message necessarily to everyone, or there are some messages you wouldn't send to everyone. And we have since implemented this into Open edX and there's an open pull request there. And it's implemented in edX preferred language now of React. And okay, bummer. Moving on. I closed the demo browser. But it's for the best. Demos are not a good idea. But what you would see is you could drag a particular subset of that histogram, and then it would change the other histograms based on the users you've selected. And then you could then further narrow down by selecting the other histograms. So they're dynamic histograms. All right, so to replicate this, you again need staff course access to edX, and you would just copy our JavaScript into a new vertical that you would create that is staff only visible, so it's not visible to students. And then in this one, you would need the daily logs. How many people work with daily event logs? Can we say a couple? Yes, a couple. All right, great. Jeff is on board too. edX will give this to you. All you need to do is ask. Whoever your data czar is. I know everyone here, this isn't an edX conference, so you may not all be edX partners, but if you are, they have that. And then you need a weekly roster of students, so you have their emails. And if you're interested in joining this pilot, I've now streamlined this process of getting in touch. If you go here, tiny.cc/edx_comm, all you need to do is click on an open calendar event, and it'll automatically sign you up for a Zoom meeting. Jeff was the victim of this once upon a time. Okay, so those are the examples I promised in the MOOC world. Okay, you got it. Yeah, please. I can end here, actually. Okay, cool. So that's in the MOOC world, but there are some developments in the on-campus world with regard to adaptivity that I want to tell you about. And there's some relation that could have to MOOCs. So what is driving adaptive systems and information systems on campus is some of the same reasons why there's interest in MOOCs and other online learning and certification opportunities. And that is there's nascent multidisciplinary pursuits like data science, where learners on campus are seeing the importance of data fluency. They may be sociology majors, they may be psychology majors, and they are frequently wanting to ask for advice, saying, okay, what course should I take given my background to get into this, right? To get some fluency in this area, right? Can you personalize some advice to me? So that I can exhibit this multidisciplinary abilities. So why do we need to do anything about this? Why aren't current resources enough? One is that while we do have faculty advisors, faculty tend to be local experts, right? They have deep knowledge in a particular area, but can't necessarily connect dots across campus. We have non-faculty academic advisors who are better able, they're broader, to connect dots across campus, but they don't have the depth of knowledge that faculty do. Machine learning models hypothetically could have the breadth of non-faculty advisors, because machine learning models could benefit from the enrollment data and so forth from the whole institution. across all majors. Could they have the depth? Arguable, probably not. I couldn't say that to any of my colleagues and get away with it, but maybe. But they lack the ability to easily tease apart the difference between correlation and causation, right? And so that's the big thing to get over. But we want to try because there's a 40% four-year graduation rate in the US and 1 to 400 or 1 to 1,000 student to advisor ratio, depending on where you go. And then of course the future of work. This is a coffee making machine in my graduate school of education building, and it is manipulating regular human coffee machines. So it's not a purpose-built coffee machine. It is replacing somebody. And we know there's going to be a lot more of this, and we're going to need to help people prepare for different careers. So there's been a lot more research in formal institutional data. At the Educational Data Mining Conference last year, I think there were 9 papers on the topic, and the year before, I think there were 2. So this is exploding, I think, for 2 reasons. One is people are getting access to their institutional data. Institutions are seeing that it is part of the mission to facilitate research and then share that data, and that research could come out of it, and then institutional benefit could come out of it. But a second reason why it's intriguing to get into institutional data research, but perhaps less so in MOOCs, is because you can have a more immediate impact on students by standing up platforms that utilize these data. Right? And these are platforms at Stanford, Harvard, UC Berkeley, which I developed, and University of Michigan, that all leverage big institutional data in some way that's student-facing. If you wanted to do this in MOOCs, let's say in edX, well, first you'd have to choose a MOOC platform, and then you would need to go through the sometimes impossible process of getting your code reviewed and checked in and just stay on them, perhaps for years. Not that I know anything about that. So here you just reap the benefits immediately by standing up local analytic platforms. And so the MOOC space in general needs to figure out how to be more nimble and allow for this kind of thing to happen. This is now future work. It's published work, but we don't have this in the recommender system. But this is a direction that my labs have been pushing against the Amazon style people who did that kind of recommendation, and more towards an explicit goal-based recommendation where the learner specifies a goal and then you help them towards that goal. So we did this, we back-tested this model in the case of course recommendation, and we used the idea of zone of proximal development to guide how we architected this model. Because we know correlation is not causation, so we need to be very careful in the design to increase the probability that what is suggested is actually sensible. So zone of proximal development says there's this collection of, let's say, problems, skills, things that you can do without any help. So for example, in the course space, it would be courses that you could take the final right now and pass it. Right? Then there's the things that you can do with help. So for example, an instructor and teaching assistants and so forth. So these are the courses you could take and then through learning during the semester pass the final. But then there are the courses that if you started right now without a significant amount of preparatory work, you would not likely be able to pass. Perhaps if you dedicated your whole life to it right now, you could do that, but that would probably require a lot of preparation outside of that class. So we consider that outside of this immediate zone of proximal development. So the idea with the recommender is for the student to indicate what is their target course. So let's say it's some data fluency course they want to take. That's the target. And then we come up with what course that's in their zone of proximal development, so it's within the what can I do with help, that if you take it, we also predict you can then pass the target course. That'll bring the target course into their zone of proximal development. But in order to do this, we need to do things like estimate if a student will pass a class, given their history. That model also has to kind of implicitly encode prerequisite relationships, and then also be able to estimate what the kind of value add to the learner's knowledge that course represents if they pass it. And we found some favorable results where we're predicting the grade pretty well. We're finding 45% of the on the books prerequisites that we're inferring just based on enrollment patterns. And then we looked to see, if we go back 4 semesters and we look at only students who all took a historically difficult course 2 semesters from then, and we look at the students who followed one of our courses that we would have recommended at that point. And then we looked at students who did not take a course that we would have recommended at that point. And there was a 22% differential in outcomes on that historically difficult course if that student took a course that, in hindsight, we would have recommended. It's not a gold standard test. It's just as good as we could come up with historical data. And because of that, I'm not confident enough yet to put this into practice. I would want to test this with instructors to say, here's a sequence A, here's a sequence B, one of those generated by an advisor, the other generated by our system. Please rate which one you think is better. That would give me more confidence that are we at advisor level suggestions or not. Okay, so wrapping up here, can this MOOC and on-campus world be connected? Because there's exciting things going on in both places. And one place to look for that is ways in which we've connected courses at different institutions. So this is still in the on-campus world, but we're connecting a course from, let's say, Laney College to a course at Berkeley. This is called course articulation, using enrollment patterns and catalog descriptions to do that matching. And what it is essentially doing is taking one space of courses, this is Berkeley, and then another space of courses, which is Laney Community College, and then finding an alignment of those spaces, right? So if you could do that and find that alignment between 2 formal institutions, why not do that between a MOOC platform and all of its courses and an institution and all of its courses? There's no reason we can't do that kind of connection. So, in closing, my vision for the future is take this ability to make real-time suggestions based on data, plus this orientation of suggestions towards a user-chosen learning goal, and then add to that this rich interconnected educational resources environments. And then I think what we can get is more on-ramps for learners to higher ed and careers for the future. And with that, I'll take questions. Thank you.